Hello everyone, welcome back to my channel. Today's topic is ellipse. So standard form of ellipse is x square by a square plus y square by b square equal to 1. And here a will be greater than b. Center is 0, 0. Eccentricity is denoted by small e. And formula is, which is given by b square equal to a square 1 minus e square. Here e is always less than 1. The major axis, see the figure here, the major axis is on the x-axis and the minor axis is along the y-axis. So our length of the major axis is twice a and length of the minor axis will be twice b. The foci will be plus minus a is 0. That means on the right side the foci will be plus AE comma 0 and left side coordinate for the foci will be minus of AE comma 0. Here S and SS are the foci. Focus. And the directrix are given by x equal to plus minus AE by E. Length of the lattice rectum is given by 2b square by a and semi-lattice rectum will be only b square by a. No need to write the 2 for the semi-lattice rectum. We have another form of ellipse. We have same form, but here in this equation our b will be greater than a. In the previous equation our a was greater than b. Here b will be greater than a. So since b is greater than a, so our major axis will be the y-axis and our minor axis will be the x-axis. Center and eccentricity will be same as the previous one. Major axis length will be twice b, minor axis length will be twice a, foci will be 0 plus minus be, directrix will be y equal to plus minus b by e, and lattice rectum is 2a square by b, and semi-lattice rectum will be a square by b. Now, let us see what will be the equation of tangent to the ellipse at the point x1, y1. It will be x1 by a square plus y1 by b square equal to 1. And normal equation will be x minus x1 by x1 by a square equal to y minus y1 the whole divided by y1 by b square. Or we can write like this also. A square x by x1 plus b square y by y1 equal to a square minus b square. Next, the line y equal to mx plus c will be tangent to the ellipse. This tangent, whenever this condition will be satisfied. Condition is c square equal to a square m square plus b square, or c equal to plus minus root over a square m square plus b square. So this straight line will be a tangent to the ellipse when this condition will be satisfied. Next, the equation of any tangent to the ellipse is y equal to mx plus root over of this one. From where we got here c, this was the value for c. So your point of contact will be minus of a square m by c, b square by c. Parametric equation of ellipse will be x equal to a cos theta, y equal to b sin theta. These are the parametric equations of an ellipse. And at the point a cos theta, b sin theta, our tangent equation will be x by a cos theta plus y by b sin theta equal to 1. And our normal equation will be at the same point a x sec theta minus of b y cosec theta equal to a square minus b square. These are the equations of tangent and normal for this point. Auxiliary circle. The circle described on the major axis of an ellipse as diameter. The major axis will be the diameter of the circle. Then this type of circle is called auxiliary circle, and its equation is given by x square plus y square equal to a square. Here b square, b and a are same. For the circle, B will be equal to A. Let us take one example. Prove that the line Lx plus my plus n equal to 0 is a tangent to the ellipse x square by a square plus y square by b square equal to 1 if we have to prove this condition. We have given that this is a line. This line is a tangent to this ellipse when this condition is satisfied. So we know, I have already told you that if this line y equal to, we know that the line y equal to m, previous it was mx plus c, but since in the question we already have m, so I have written here m dash. So y equal to m dash x plus c is a tangent to the ellipse, this one, if c square is equal to a square m dash square plus b square. So our given line and given equation, let us write the given line and the given equation of ellipse. This was the given equation of ellipse and this is the given line. From here, from this equation, Lx plus my plus n equal to 0. From this equation, we will try to convert that equation in this form. Y equal to m dash x plus c. From there, we can easily find the value of m dash and c. See how we can do. Take Lx and n to the right side, it will be minus, and shift this m to the right side, minus L by m, x plus minus n by m. See, we can now compare these two equations. In place of m dash, we have here minus L by m, and in place of this c constant, we have minus n by n. So we can write here our m dash will be this one and c will be this one. We will now put these two values in this equation. This was the condition. So we will put the values and we will find the required condition. So let us put the value in this equation. C value was minus n by m. M dash value was minus L by m. So this will be n square by m square, L square by m square plus b. Take m square LCM on the right side, you will get a square L square plus b square m square by m square. So both side m square, denominator will get cancelled. This is the required condition. Next question, prove that the line Lx plus my equal to n is a normal to this ellipse if, again we have to prove one condition, line is given and ellipse is given. But now we have normal. Suppose the line Lx plus my plus n, this line, let us mark that as equation number 1, is a normal to the ellipse, this one, at the point a cos theta, b sin theta. That means this line is intersecting the ellipse at this point. This line is normal to the ellipse at this point, a cos theta, b sin theta. So what will be the equation of normal? The equation of normal for this point, I have already given the equation of normal. Wait, I am again showing. Yeah, this one. The equation of normal at a cos theta, b sin theta is this one. So we will use this equation. So see here, I have written the equation of normal using this point. Now we will compare these two equations, equation 1 and equation 2. Here with x we have a sec theta and here with x we have L. So what we will write? A sec theta by L. Here with y we have minus of b cosec theta and here with y we have m. So we will write minus b cosec theta by m, and on the right side is a square minus b square by, it will be n. Okay. Now we will take the first and the third ratio and this one equal. I have written the first and the third one here. So sec theta we can write 1 by cos. Take this cos to the right side, you will get a by L, a square minus b square by n cos theta. And same here, cosec theta, right? 1 by sine. Take sine to the right side, you will get this equation. So now what we will do, we will square both sides of 3 and square both sides of 4, and we will add the result. 3 square plus 4 square, left side will be e square by L square, and here from left side we will get b square by m square, add them, plus here also we have this bracket portion and this bracket portion are same, so we can take them common, and don't forget we are squaring the equations, so we have to give this square. So our remaining term will be cos square theta plus sine square theta, and we all know this will be equal to 1. So this was the required condition which we had to find. Next question, if the normal at an end of a lattice rectum of an ellipse passes through one extremity of the minor axis, show that the eccentricity of the curve is given by this equation. Now you can see the figure. This is the tangent and LL dash is the lattice rectum, and okay, let us start the problem, then I will tell what will be the rest of the points. The equation of the ellipse is, this is given, this equation is already given. Now the coordinates of the extremity L, see here, L is the extremity of the lattice rectum LL dash, LL dash is the lattice rectum of the ellipse, R. So here L coordinate will be AEB square by A. Okay. So what we can find, see here, this line is the normal, this one LB dash is the normal. So our equation of the normal at this point L, we already have the coordinate of L. Let me write AE comma B square by A. This was the coordinate of L. So at this point the equation, see the normal is touching the point L. So equation of the normal at this point will be, original equation was x minus x1 by x1 a square and y minus y1 by y1 b square. So in place of x1 we will put AE, and in place of y1 we will put b square by A. So we will get this x minus AE by AE by A square, y minus b square by A, b square by A, b square. Now the normal passes through the eccentricity 0 minus b of the minor axis. See the figure here. See, this normal is passing through this point. What is our this point? This is the minor axis. So this point, what was the length of the minor axis? Twice of b. That means this from b to O it is b, and from 0 to b dash it is b. And this point will be our 0 comma minus b. Since this point lies on the y-axis, so obviously our x will be 0 and our y is minus b0. Now this normal is passing through 0 minus b. That means the equation of the normal will satisfy this point 0 minus b. That means we will put 0 in place of x and minus b in place of y. So putting 0 and minus b in place of x and y, you will get this equation. In the normal equation we have to put 0 and minus b. The normal equation was this one. See here, can you see? This was the normal equation. This will be 0, and in place of y we will put minus b, and then we will simplify it. We will get our answer. See here, I have put here 0 minus b. So let us simplify this one. A cancel. It will be minus of a square, and we can take a as the LCM. It will be minus of AB minus B square, and A will get cancelled. So since we have all the terms minus, so we can make them positive. And we know that this formula, b square is equal to a square 1 minus e square. We know this formula. So what will be our b here? From this one we can find b will be equal to root over of a square 1 minus e square. So in place of b we can write a into root over 1 minus e square, and b square we can write directly. So a square we have here a square, we have here a square. We can cancel all the a square. Remaining will be 1 minus root over this one plus this one. So see here plus 1, and also we have here plus 1. We have plus 1, both side it will get cancelled. Take this e minus e square to the left side, it will be e square. And to remove this square we need to square both side. To remove this root over, square both side, you will get e to the power 4, 1 minus e square. Take all these two terms to the left side, you will get the required equation of the normal. Next question, prove that the tangent and normal at any point of an ellipse bisect the external and internal angles between the focal, it will be 1L, focal radii of that point. See here, this is the ellipse. We have to take one P point x1, y1. This is our foci. This is the normal, and P is the normal, and PT is our tangent. Let the equation of the normal, take the, the ellipse, equation of the ellipse to be this one. So px1 y1, we have taken this point px1 y1 here. So we have to write that we have taken this point on the ellipse. Now the equation of the normal at P was this one. This one the equation of normal. Earlier we used to write this a square below x1 and this b square below y1, but it is okay to write a square in the numerator also. Now see, let the normal, this equation, this normal, let the normal 2 meet the major axis at n. The normal 2, see here, this normal is meeting the major axis. What is the major axis of this ellipse? Major axis is obviously the x-axis is the major axis, and y-axis is our minor axis. So the normal is meeting the major axis at the point n. So what will be the coordinate of this point n? Since n lies in the x-axis, so obviously our y will be 0. In x-axis, y value is always 0. We know that. Now we just need to find the coordinate of x. So how we will find? We will just put 0 in this equation of the normal. We can find the value of x or the coordinate of x from that point, from that equation. So in place of this y, let us put 0. So our equation will become this one. Just put 0 here. y1 will get cancelled. You will get minus of 1. Take this x1 to the right side, and we know b square value. B square value is a square 1 minus e square. Put that value. We need to simplify this one a little bit. A square x minus of a square x1. This will be a square into 1 into x1, then minus plus e square x1. So from both sides we can cancel these two terms. These two terms cancel. Then remaining will be a square x, a square e square x1, and a square x square will get cancelled. X will be equal to e square x1. So what was our x? Our x, see from the figure, from 0 to n is our x. Since this is in the x-axis, so obviously our x is from 0 to O to n. That means our ON is the value of x. So in place of x, I'm writing ON here. ON will be equal to E square x1. So from here, from the figure, what we can find Sn. See how we can find. See from the figure, this was the figure. How to write Sn? See, this is our Sn. To find Sn, what we will write? We will write OS minus of On. Why? Because we have the value OS. Since S is the focus, so our OS value will obviously AE, and we have just now find ON value. So we will subtract ON from OS. We will get our SN. We will get this part. And similarly, we will find the value of Sn. To find Sn, we have from 0 to S dash, we have the focus value AE. 0 to S is AE, and our ON we have found just now. So what we will do? We will just add these two values, ON plus OS dash. We will get our S dash N. Okay. So see here, I have to Sn will be equal to OS minus On. So OS value, which is our focus, is AE, and On we have found just now. We can take E common, which will be A minus EX1, and this we can write as SP. From where we can write? This is a property of focus. See here how we can write SP. This was our S, this was our P. So our A minus EX1 will be our SP. Okay. So see. So here we got our Sn is equal to ESP. And our Sn dash, I have already explained this one. We need to just add the values. You will get A plus EX1. For plus, it will be the left part. See here. This will be for plus, it will be S dash P. This part. This one. This line S P. S dash P. So here I have written S dash P by property of focal. Therefore, from these two equations, what we will get? We will get Sn. If you do Sn divided by S dash N, Sn divided by S dash N, then right side will be ESP divided by ES dash P. EE will get cancelled, so we will get SP by S dash P. So from here, what we can say? We can say that the normal PN, our PN was the normal and our tangent was PT. So normal PN bisects the angle S dash PS between the focal radii of the point P in the triangle PS S dash. See here. This is our Sn, this is our Sn, and this is our S dash N. We got Sn divided by S dash N is equal to SP divided by S dash P. And so, from the property of triangle, what we can say? That the normal bisects this angle. And we know that, sorry, we know that the tangent PT is obviously perpendicular to the normal. We know here. We can see from the figure the tangent is perpendicular to the normal. Is perpendicular to the normal PT, and therefore the tangent PT is the external bisector of the angle SP S dash. See here, this was SP S dash. The PT is the external bisector and the normal is the internal bisector, which is inside the triangle, and the tangent is outside the triangle. So this is the tangent will be the external one and normal is inside the triangle, so that will be your internal. Okay, so that's all for today. Thank you.